A cosmic spectacle is unfolding right now, capturing the attention of astronomers all around the world. Betelgeuse, the mesmerizing red supergiant that marks the shoulder of Orion, is undergoing a stunning transformation. Its brightness, the glow that gives it such a distinct presence in the sky, has surged far beyond what's typical, rising by an incredible 50%. At the start of this year, Betelgeuse ranked as the 10th brightest star in our night sky. But with this sudden increase in luminosity, it's now climbed up the ranks to become the 7th brightest star we can see. Betelgeuse is a massive star nearing the end of its life. It's so enormous that if it were placed at the center of our solar system, its outer layers would stretch all the way to Jupiter's orbit. Eventually, this giant will collapse in on itself, triggering a powerful supernova explosion. This dramatic end could result in either a neutron star or a black hole. What makes this even more exciting is that when Betelgeuse does go supernova, it's expected to be an extraordinary sight. Situated about 650 light-years from Earth, we're in a perfect spot to witness this spectacular event. When the explosion happens, it will begin with a flood of neutrinos racing across Earth, picked up by detectors around the globe. Soon after, high-energy photons will burst through the growing cloud of stellar debris, causing Betelgeuse to brighten dramatically over the span of a week, potentially reaching a brightness 100,000 times stronger than usual. Depending on how powerful the explosion is, Betelgeuse could even outshine a full moon and might be visible during the daytime. At night, its glow could cast actual shadows. This brilliant display won't just be a fleeting moment. It'll linger, giving astronomers a rare and extended chance to study the event in depth and possibly make discoveries that change what we know about stars. While the idea of a supernova might stir fear or speculation, especially given its association with omens in the past, there's no need for concern. We're far enough away that Betelgeuse's death won't harm us in any way. To understand how we got here, we need to look back to the end of 2019 when Betelgeuse started behaving strangely. It began to dim noticeably, even visible to the naked eye. Using the Very Large Telescope, astronomers captured optical images of the star and found that while it looked symmetrical, its outer layer, the photosphere, was showing signs of major disruption. This is a part of the star where its light is emitted, and what they saw was that the photosphere had started to expand, making it seem as though Betelgeuse was swelling from our point of view. That expansion kept going steadily at about 8 kilometers per second through most of 2019 until mid-November. That's when things started to shift. The outward flow of material from Betelgeuse slowed and eventually stopped. New images taken after that revealed two unexpected developments. First, a dark patch had formed in the star's southern hemisphere, creating a dramatic contrast from earlier observations. Second, the surface temperature of the star had dropped by about 80 Kelvin. Between January 27th and February 13th of 2020, Betelgeuse reached a historic low in brightness, its faintest point in recent memory, just about a year after the flow of material had ceased. But after that low point, the star began to brighten again, slowly returning to its usual magnitude over the following months. This raised a big question. What exactly had happened to Betelgeuse? All the evidence pointed to a colossal and unprecedented event known as a surface mass ejection, or SME. This phenomenon is somewhat similar to coronal mass ejections we've seen from the Sun, but on a dramatically larger scale. To visualize AMI, imagine a volcanic eruption but on the scale of a star. Material from deep inside the star bursts upward and outward, sending shock waves through its atmosphere. Eventually, this material cools, forming molecules and dust that block part of light, making the star appear dimmer from Earth. In Betelgeuse's case, was beyond anything previously observed. It ejected a mass 400 billion times greater than what's typical in similar stellar events or solar CMEs. That's multiple times the mass of our moon, all hurled into space at unbelievable speeds. This was the first time astronomers had ever witnessed such a massive outburst from a star's surface. Thanks to this event, they were able to observe surface-level details in real time using the Hubble Space Telescope, giving us a rare window into the life and aging process of a dying star. The theme had a major impact on Betelgeuse. It lost a massive amount of its outer layers all at once, far more than what it usually sheds each year due to its stellar wind. In a sense, The star violently tore off part of its own surface, and now it seems to be slowly healing from the trauma of that explosion. But after this dramatic dimming event, Betelgeuse's behavior started to change. It used to pulsate, fluctuating in brightness on a 400-day cycle. Now, it pulses every 200 days. As a semi-regular variable star, Betelgeuse naturally goes through cycles where its brightness changes due to shifts in its size and temperature. There are two main pulsation periods. The first is 400 days believed to result from fundamental mode pulsations. The second is much longer, about 5.6 years, and its cause remains a mystery. To better understand the changes, scientists ran detailed computer simulations. Their model suggests that a superheated current of gas, imagine a massive, intense bubble formed deep inside Betelgeuse and rose to the surface. These hot gas bubbles can form due to the star's chaotic and convective outer layers, which behave a bit like a pot of boiling soup with hot material constantly churning and mixing. As this bubble of hot gas burst through the surface, it caused the star to eject a massive amount of material and also disrupted its usual pulsation pattern. While the outer layer expanded, the deeper parts of the star contracted. This internal conflict caused a shift from a 400-day pulsation to a much faster 200-day cycle. Astronomers believe this abnormal pulsation won't last forever. They predict that over the next 5 to 10 years, the star's internal rhythms will stabilize again, gradually bringing Betelgeuse back to its original 400-day cycle. As for when Betelgeuse might finally explode in a supernova, astronomers say it could happen any time within the next 10,000 to 100,000 years. Based on its characteristics, its color, brightness, size, and age, scientists believe Betelgeuse is currently in an early phase of helium to carbon fusion. This process must continue to the fusion of heavier elements, oxygen, then silicon, and finally iron. Once the star's core is saturated with iron, fusion can no longer sustain it, and the core collapses under its own gravity, resulting in a catastrophic explosion. But since Betelgeuse is about 650 light years away, if a supernova were to happen right now, we wouldn't see it until 650 years from now. The light from that explosion would still be traveling across space, which makes it extremely unlikely that anyone alive today will witness that final moment. What makes Betelgeuse truly unique is that we can actually observe its surface, something we can't do with most other stars. This rare visibility offers astronomers an unprecedented chance to study the late stages of a massive star's life. It's through this kind of detailed observation that events like the surface mass ejection were detected, something that could completely change how we understand the death throes of stars. Recently, astronomers came across a spine-chilling discovery that takes things even further. For the first time ever, they witnessed a star devour its own planet, a staggering 12,000 light-years away, in the constellation Aquila. This rare observation hints at the destructive power that dying stars can unleash, not just through explosions, but through acts of celestial consumption that rewrite what we thought was possible. Betelgeuse, with its unforgettable name and commanding position in the night sky, has fascinated humans for centuries. But its importance isn't limited to astronomy. This star has etched itself into global mythology, folklore, and pop culture, inspiring everything from ancient beliefs to modern storytelling. The name Betelgeuse comes from Arabic origins. It was originally interpreted as the armpit of the giant, although some scholars believe it might actually refer to a hand or shoulder instead. This anatomical theme is carried through various interpretations, with Betelgeuse often linked to human or animal figures in mythologies around the world. In ancient Japan, Betelgeuse symbolized a severed limb. In Brazilian tradition, it was viewed as a turtle's leg or a caiman's hind limb. In Hindu astrology, the Sanskrit name for Betelgeuse means the moist one tied to the ardor lunar mansion and connected to Rudra, the fierce storm god. Across different cultures, Betelgeuse has been more than just a star. It has been a symbol, a sign, and sometimes an omen. In Macedonian tradition, Betelgeuse represented livestock and farming life in rural villages. On North Baffin Island in the Melville Peninsula, the rising of Betelgeuse marked the beginning of spring and longer days, a celestial signal of seasonal renewal. Its cultural status is also bolstered by its prominent placement in the constellation Orion, where it shines as a star on Orion's right shoulder. Among the brightest stars in our sky, currently ranking 11th in luminosity, Betelgeuse continues to stir imagination and creativity. Artists, authors, and filmmakers have all found inspiration in its glow. There's still so much more to uncover when it comes to Betelgeuse, its changes, its fate, and what it tells us about the life and death of stars.